Hi there, welcome back. I'm Humayra, and today we are going to be looking at part 2 of rational functions. Let's get started. In our previous video, we dealt with shifting asymptotes, and if you would have noticed that for all the curves we ended up with something that looked like this. And to be honest, that is a bit boring. So today we'll try to change things up a bit and see what we can come up with. Now our first curve for today is y equals to 2x squared plus 2x plus 1 by x squared plus x minus 1. And now if you remember, our first step was to find the vertical asymptote. And to do that, we take the values of x where our denominator is 0. So if we take x squared plus x minus 1 equals to 0 and solve, we get x equals to 0.618 and x equals to minus 1.618. So these are two values of x for which our denominator is 0. Now, a quick recap. When we take these values of x, our denominator becomes 0. So that we end up with y equals to something by 0. Now, since this isn't possible, anything divided by 0 is infinity, we consider these values of x as our vertical asymptotes. So x equals to 0.618 and x equals to minus 1.618, these two lines will be the equations for our vertical asymptotes. Now moving on, to find our horizontal asymptote, we will simply be dividing the coefficient of x squared in the numerator by the coefficient of x squared in the denominator, which is 1. So if we divide 2 by 1, we end up with 2. So y equals to 2 is our horizontal asymptote. Now, if you are curious as to why that works, feel free to check my previous video where I explain this in detail. Now, our next step is a little bit different. We will be going a bit astray from what we did in our previous video. And for this curve, we will also be finding out the turning points. Now, how do we do that? So, for starters, we simply take dy by dx as 0 and then we solve. So we end up with x equals to minus 0.5. Now I know this looks like a lot of working, and if your answer doesn't match with mine, feel free to pause the video and check it out. And if you have any further queries, please comment them down below. So here we have our turning point, minus 0.5 and minus 0.4. Now all we have to do is sketch it in our asymptotes and try to figure out a general shape of the curve. Now, as we've already found out, we have asymptotes at x equals to 0.618, x equals to minus 1.618, and y equals to 2. And our turning point is somewhere around here. Now, remember that you're just sketching a curve and not plotting it. So the locations as to where the particular values of x's and y's are, they don't necessarily have to be accurate. But all those things have to look approximately cohesive so that it does look like you approximated where the values of those x and y's could have been. Now, so this is where our turning point should be. And you'll notice that now we have three separate regions of x. We have our far left portion, we have a middle portion, and we also have a far right portion. Now, for our left part, we will be putting in values that are less than minus 1.618, and if you do that, you'll see that we end up with a curve that has somewhat of a general shape like this. Now for our far right part, if you put in values of x that are greater than 0.618, our curve looks like this. And in the middle part, if you put in values that are between minus 1.618 and 0.618, we will get this. And that's all. Now for our next curve, we have y equals to x squared minus x minus 2 by x squared minus x plus 5. And now if you'll remember, our first step was to find the vertical asymptotes, and for that we take our denominator as 0. So let's take x squared minus x plus 5 as 0, and then if we solve, we get x equals to 1 plus minus root 19i by 2. Now, what does I represent? Now, since we have an I in our root, this shows that our roots are complex. Now, what does that mean? This means that for any real value of x, if we put it in our denominator is never going to be 0. So, what does this show? This shows that this curve does not have any vertical asymptotes. And then we move on to our next step, which is finding the horizontal asymptote. Now, what do? We divide the coefficient of x squared in the numerator by the coefficient of x squared in the denominator. So if we divide 1 by 1, we end up with 1. So y equals to 1 is our horizontal asymptote. Now, similarly, our next step is going to be to find the turning points. So what do we do for that? We take dy by dx equals to 0 and then we solve. So we should end up with x equals to 0.5, and if we put that value of x in our equation, we should end up with y equals to minus 0.474. And again, this is a pretty long working, so feel free to pause the video and take a closer look at the working. Now, all we have to do is sketch in our asymptotes and figure out the shape of the curve. Now, we have one asymptote at y equals to 1, and this is a horizontal asymptote. And our turning point should be somewhere around here. And if we put in values of x from anywhere from minus infinity to plus infinity, the general shape of the curve should look something like this. So that is all for today's video. Thank you so much for watching, and if you have any queries or suggestions, please comment them down below. And stay tuned for my next video where I talk more about sketching curves.